Good afternoon, everyone. My name is Hassan. I'm from Strukton Power, and today I will be talking about Strukton Power in European markets. A bit about my background. I've been working in renewable energy for 5 years now, and for the last 2 years, I've been working for Strukton Power, and specifically for battery energy storage systems projects. And I help Strukton Power in looking for investments and developing solutions for companies within Europe to actually meet the European demands for energy and meet for the future goals. My goal for the presentation is that we can look at the opportunities we have in the European market together and see how companies in Taiwan and enterprises in Taiwan can contribute in reaching our goal. So for the agenda today is zero emissions in EU and Netherlands. I talk about how Europe has set goals and for the zero emissions, how Strukton Power contributes to goals within EU, what do we do, how do we do it, and who we work with to meet the goals with EU, our projects and business opportunities for Taiwan enterprises. Here are some examples of the project that we are doing, what challenges we face, and what kind of opportunities companies in Taiwan can have. And then I talk about Europeans' dependence on renewable energy and battery energy storage systems. That BESS is a short form for battery energy storage systems. Here we'll learn more about how we are depending on renewable energy in Europe, and again, what type of opportunities we will have to contribute towards these goals. And at the end, I will talk about suggestions for Taiwanese enterprises specifically. It will be a picture of what we are done and what type of opportunities we can have. So starting now for zero emissions in EU and Netherlands. So Europe itself has been working towards policies that can be fit to meet the demands for cutting the greenhouse gas emissions. So they make policies for forestation, for renewable energy, and all 27 member countries work together and share the chair to meet these requirements. And the limit that has been set for 2030 is 55% reduction in the greenhouse gas emissions. And for Netherlands, it has been the most ambitious goal for 49% for reducing the greenhouse gas emissions and 95% by 2050. So learning about that, if we now look how Strukton Power, my company, is contributing to goals within EU. Our forte has three departments: power electronics, grid solution, and digital twin. For power electronics, what we do is that we make our own power electronics and we use that those building blocks to make high-tech solutions like battery energy storage systems. And once we are done in that, or maybe traction drives, whatever those solutions are, once we are going to implement those solutions, we use our own power electronics and develop our own power electronics. Grid solutions is a department which focuses towards working with the companies or TSOs, transmission service providers, and we help in setting up grid substations and high voltage networks. And our department, once like the system, like battery energy storage system, when we develop it, they help in putting it and install it. So civil installation works. Digital twins is something like on railway tracks, when you know where when your railway carriage is. So that is position-based system. So we can track the positions, remotely monitor it. This is what digital twin does. These are the three main departments Strukton Power is. Our sister company, Strukton Rail, they are Europe's biggest contractor for maintaining railway tracks and railway overhead lines. So they have subsidiaries in Italy, France, Belgium, Sweden, and Netherlands. What they do is that they have heavy equipment. These can be up to 20 foot or 18 foot, as big as a volleyball court. And these machines actually make sure the tracks are in place, and we feel safe when we drive, or overhead lines when they're under construction, so they turn off. So they're heavily dependent on sometimes on diesel equipment or electric equipment which is charged by batteries. So these are the, and we are helping them actually meet the climate goals of using all electric equipment or zero emission equipment by 2030. So they can't really use these diesel equipment by the end of 2030 because of the European requirements and Netherlands requirements as well. So this is a business opportunity which Strukton Power took, and our projects are heavily focused towards reducing these diesel locomotives and diesel equipment off the railway network, and we help the Strukton rail to actually meet the requirements. And this is what our opportunities for Taiwanese enterprises will be. I will talk about the project Strukton battery locomotive. I'm the lead for the project as well. So this was an R&D project. If you see on the left, there is this locomotive, which is in yellow, probably you can see it, and it has a very long freight in the back. So usually it works on, it's an electric locomotive, and it takes energy from the overhead line. So what happens is that once that overhead line runs out, or when you do not have overhead line, or there is no voltage because of maintenance, we need to have a solution in which we can move this locomotive with 300 tons of weight behind it to a spot. So for 4 kilometers or 10 kilometers. So we did some calculations. We saw, okay, we have to do some low speed movement or low speed shunting. And for the last mile, this is for a last mile battery solution. So we put, if you look here, we have this container, which is a 20-foot container on a 60-foot wagon. We place all the batteries inside, all the hardware equipment, electrical hardware equipment inside it. And with 250 kilowatt hour of battery storage, we are able to operate it for more than an hour. And for this specific project, our challenges were finding the right battery suppliers. The catch here is that the equipment we have to use should be railway standards, and railway standards are really high in regards to the G-shock. So shock and vibration, it should be should be 5G, and although it should be maintainable and should be fire safe, and it should contain fire for 15 minutes. And you cannot actually operate in tunnels if you are not of a certain fire limit. So we really had struggle finding the right equipment. Now we are working with the suppliers in Germany, and the delivery times are really high. And I will show you in the next slide how that container looks like. That's an energy storage system, and I will point out what type of equipment that we are interested in. So here you see the 20-foot container. We have fine ventilation, so it should be cooled down. It has connection on both ends, so it can be connected from both sides. It has a safety switch so that we can maintain it. But the important thing that you have to see now is that energy density of the batteries. So you see there are two on this side. They have two batteries. There are two battery systems. There's this e-boxes, so the connection systems, and these battery systems are their energy density is quite low because of the shock and vibration, and they're 2 tons in weight, so it's high in weight. So we are looking for smart solutions in future, and these are lithium-based batteries. And if you look now, this part is coolers for the batteries, and this is magnetics, which is also again relying on the delivery system, the delivery part. And these two cabinets, I will show a bit. These two cabinets are where all our power electronics is, which I will talk about a bit later. So the next project that I'm going to talk about is diesel cranes to electric cranes. So these cranes, you see, they are specifically designed to actually operate on railway tracks. And this is one of the, they are like around 50 or around that, with Strukton Rail have in fleet, in their fleet, and all of them are diesel. So for them, it's very easy to carry diesel to the sites and use it. And if they run out of diesel, they can actually put diesel in. But the challenge now would be is that by the end of this 2030, they cannot actually use these cranes anymore because they are diesel. Either they're quite functioning quite well, but either they convert them to electric or they buy new electric cranes, which are available in market, but the delay or getting them is 5 or 6 years from now. So the best solution was that find a way to electrify them. So what we proposed to them that we remove the diesel motor and we replace it with electrical motor, and we, instead of diesel tank, we charge it with iron phosphate batteries. So basically car batteries, and we provided them with two solutions. Either we can have a removable batteries which are placed on top and you can charge them somewhere else, or you can charge them like your Tesla and put the batteries inside the space that we have in the crane. That was a challenge, mechanical challenge again, looking for right kind of motor, right kind of converters, which can actually fit into heavy equipment. So we are looking now into right kind of partners to help us supply this kind of equipment in short time so that we can start working. But the major focus was we had 360 kilowatt hour of battery storage, and we could work 10 hours with single charge with full load. So that was a challenge that we did. And we were looking towards, again, looking at these challenges and looking towards partnering with people, coming up with smart solutions. Okay, and the next topic is Europe's dependence on renewable energy and battery energy storage systems. How we see that now is that renewable energy as Europe's backbone. So in the past decade, the cost of generating renewable energy has decreased many folds. If you see now that solar was 0.40 US dollars per kilowatt hour, now it's around 10. So looking at that, Netherlands and the European Parliament actually backing up the renewable energy goal for 2030. So it's 45% production or dependence on renewable energy by 2030, and Netherlands' goal for being 100% renewable by 2050. Also, the current gas crisis is not helping Europe right now. So the thing with renewable energy is that it is very widely available. We have a lot of wind turbines, we have a lot of solar plants, but the thing is that at some point it creates there is so much renewable energy, but the grid is not sufficient, so that creates congestion on the grid. And we believe, and what Europe believes as well, that energy storage is a solution. How you see that is that if you look at if you forecast renewable energy, it's quite hard to predict, because you have solar. If you have a bright sunny day, you have 8 hours of sun or something, and then during night you do not have that. So what you can do is actually depend on solar when there is sun, and actually when you have surplus of solar, you can actually charge your batteries. And that's what Netherlands is actually going to support by 54 gigawatt of energy storage capacity by 2050, just to support these renewables in the grid. And that's why, hence, the battery energy storage systems are in place. And there are 4 applications that I will talk about in this slide. So if you have a battery energy storage system, the one that I showed you in the video, it's similar to that, and you can connect it to the grid. In that case, when I was in the video, it was connected to a railway locomotive. But now you can, if you think that the 20-foot container, but with higher energy density, you can actually store up to 1 megawatt or 2 megawatt easily in that 20-foot container. So when you have, let's say you have your own power plant, you have surplus of energy, you can store that in your own battery bank and just rely on that battery bank when you need it. So you do not rely on the grid anymore. So that's microgrid, isolated sites. You can depend on battery energy storage system for surplus of your energy. Grid support. So grid support, you can, I will talk about it a bit more, but in simple words is that if you're looking toward congestion again, you have surplus of energy, and then you want to predict at night, you want to supply that energy, so you can store that energy and supply it later on. So that's what we can do with grid support. We can help with congestion. Behind the meter energy management, that's something which all European households do. So we have solar panels on our houses. We charge them, and we sell the energy back to the grid using our own smart metering. And once we don't need that, we use that by ourselves and then sell it back to the grid. So it's quite common using behind the meter energy management. It's on every household. and there they have, instead of selling it to the grid, you can actually save it. So that's something you can do. And renewable energy production management, again, that's something, if you have, Denmark is investing in an island where they will produce a lot of offshore wind energy, and they will store that energy in battery banks and then later provide it to their mainland. So that there are a lot of ideas, but Europe is actually focusing towards battery energy storage system in future. But I will talk about grid support in a bit more. So energy trading, that's something, now Belgium and all, mainland Europe, Belgium, the Benelux region, Belgium, Netherlands, and Luxembourg, they're investing a lot. It's like we buy the energy from the grid at 20 cents per kilowatt hour. We store that energy in a battery bank. The minute the price of energy goes to 40 cents per kilowatt hour, we start to sell that energy which we just stored. That's energy trading that we do in grid support. Congestion management, I talked about a bit more a bit earlier. It's the same. We have 55 kilowatt hour or gigawatt hours of energy being produced by, let's say, by wind turbines in a day, and your grid can support only 33. So the rest can be stored in battery energy storage system. And when the wind turbine is, let's say, wind turbine and solar panels are down, you can support the 22 more when it's not available. That's congestion management. Peak shaving, I have a very nice figure for that. Peak shaving is, imagine we are in our office and all of my colleagues come to the office and start charging their car while I'm actually, we have our load, we have a lab setup here as well, so they're actually using energy. So we have this peak demand at 9 o'clock. So 9 to 11, let's say. And what we can do with smart charging is that we have this battery energy storage system, which stores the energy and which can supply energy later on when there is a high demand. So we can actually balance that demand curve. It's in a very simple way. It's being done actually with smart charging all over Europe, and it's quite common now because there is not enough grid capacity. In order to get connection to the grid, you have to apply 2 years in advance. So that's something the TSO, the transmission service operator, does that by itself, and they hire us to actually, once they have the permit, they hire us to actually start working on the installation side. But we do not take care of the permit. The permit is then taken care of by the TSO. So that's what we are heavily depending on the grid storage system in Europe, and how we can actually tackle a few things. There are other things that can be discussed, but I tend to focus on these things. So what we predict now, that by the year 2030, only in Netherlands, we predict 750 megawatts of battery energy storage systems in the grid. So, and the companies are heavily investing, and we are actually looking for partners who can either provide us the containers. Actually, I will show you in the next slide what is our prototype that we are building now. So we buy the container and batteries from a supplier in China, and then we put our own power electronics in it. And this container can be 10 containers or 20 containers that can be connected together and can supply to the grid, or can be connected to the solar panels and then store the energy and supply to the grid. So they're easy to connect. They're portable. They can do all the things that I just said. And yeah, the challenge is for us, again, find high powered batteries in a very short amount of time and can be delivered, and they are actually compatible with our systems. So that's something we're looking into. But the problem is not just here. Our challenges are not just here. There are other equipments as well. So our basic equipment when we make these systems are power modules. These are in-house developed power modules that we built by ourselves, which have different functionalities depending on the power required. So if you see, there's a low power module which can take up to 400 kilowatts of power. Then we have medium power module which can take 800 kilowatts of power, and For high power, we have up to 1600 kilowatt hour. And each power module is built up of IGBTs and specific PCBs and semiconductor and switches. And we have to rely on our suppliers, and now we are actually working with a supplier in Netherlands who imported from China. But we heavily rely on these equipment to actually make these power modules, and we have orders of 200 or 100 even, depending on the type of the requirement, because each power module can be used as a traction drive. So for railway, and each actually they were built for railway, now being used in the battery energy storage or in substation and grids now. So they're high quality and high quality modules which are placed in now grid as well. So that's why we have high demand for this. But then we really depend on these kind of materials to be delivered so that we can meet our demands. They are built in our production facility in Enschede. So again, there is an opportunity where there is a challenge, there is an opportunity, and we really looking forward to collaborate with people, with companies in Taiwan. So suggestion for the Taiwanese enterprises, I would say, is look at what we are doing now. So what I've told you now, it's a full cycle. We do our own power electronics, then we build our own energy storage. Once we have built that energy storage, we actually install that energy storage in a specific grid setting, and we can also monitor these by our remote monitoring. So if you look now, if you're interested in energy storage, talk to us. If you're interested in just converters, talk to us. If you are interested in heavy high-tech solutions with which are installation to the grid, talk to us. And if you're looking into data monitoring, these are all opportunities which can be in which we are actually looking to partner up with the right kind of people who can provide us good quality solutions which we can build together. And our goal at the end is to actually meet the green initiative that EU has. And there is a lot of demand right now to actually to take part in the European grid right now. So I hope that we can actually partner up in future with Taiwanese enterprises. And if you want to get in touch, please get in touch with me or Michelle Strasse, our sales manager. And even if you get in touch with me, if you have questions, I can get in touch with the right person, so where we can actually talk in future. I'm very hopeful that this was informative, and hopeful that we can work together in future. Thank you.